Let's take a look at a question on application of differentiation. We have here a curve C given by the equation of 2y cubed minus y squared equal to x e to the power x. And we are supposed to find the equations of the tangents which are parallel to the y-axis. I'm supposed there should be more than one tangents that we need to find, since the questions use plural for the equations instead of singular. Anyway, let's write down the equation first. We have a 2y cubed minus y squared equal to x e to the power x. I think for this type of question, it might help if we can draw a rough sketch. A rough sketch basically means it's our own reference. It's not really the actual graph of this equation. It's to help us to give us a guide of how the curve is together with the tangent we are supposed to find. Like here, for example, we can just imagine the curve to look something like this. And since the question wants us to find the equation of the tangent that is parallel to the y-axis, perhaps I think they are actually asking us to find the equation that is this. That means the equation, I'm supposed it should be taking on of the form of x equal to k or x equal to h. Alright, so now we know that we are supposed to find like x equal to h or x equal to k, and the tangent is parallel to the y-axis. I think we should be trying to find our dy dx first, and we will be setting our dy dx to be undefined, since the gradient of the tangent is parallel to the y-axis. I'm going to do an implicit differentiation. I will just write differentiate with respect to x. And differentiating this respect to x, I will get a 6y squared dy dx. Here, I will get a 2y dy dx. Here, I'm going to make use of product differentiation. I'm first going to keep my x, differentiate ex, I will just get ex. Now, I'm going to keep my ex. I'm going to differentiate my x, I will get a 1. Re-expressing our dy dx in terms of the rest, I will be able to get a x e to the power x plus e to the power x over 6y squared minus 2y. Perhaps I will just make it slightly nicer by factorizing out the common terms. For the numerator, I'm going to take out e to the power x. This is left with x plus 1. Here, I'm going to factorize out a 2y. I will left with a 3y minus 1. Right? And we will be setting the denominator to be 0, since we know that the gradient is undefined. Here, I will just set 2y, 3y minus 1 equal to 0. From here, I will be able to get y equal to 0 or y equal to 1/3. And for y equal to 0, I can just quickly sub this one back into our original equation, which will be getting me x equal to 0. So in fact, x equal to 0 is one of the tangent that I need to find already. And for the other tangent, I'm going to sub y equal to 1/3 into here. So I will get a 2 1/3 cubed minus 1/3 square equal to x e to the power x. And simplifying this, I'll get x e x equal to minus 1 over 27. And I will get a x e x plus 1 over 27 equal to 0. This is not exactly quite a nice equation to solve. I think I'm going to make use of our GC to solve this particular equation here. Okay, here I'm going to set my equation to be y1. This one I'll have key in y1 into my GC. And for y2, I'm going to set equal to 0. Because later on, I'm going to make use of the intercept function. Of course, it's not really necessary because you can actually just key in y1 and use the 0 function. But I think it's slightly faster if I have to make use of the intercept function from the GC. So now we have y1, y2. I'm going to graph it. And here, I feel that there might be two solutions. I'm going to find the first one first. Second, trace. Then I'm going to trigger the intersect. Okay, I will just move somewhere close to the first intersection, and I will just enter 3 times. Okay, and it will give us the first solution. I will get x equal to is a minus 0.0385 to 3SF minus 0.0385. let's find the other intersection. Second trace, I'm going to go intersection. I'm going to shift somewhere around here. This is the other intersection which I suspect to be, and the 3 times. Okay, I will get a x equal to minus 4.8823 SF. So in fact, based on our diagram, right, we know that actually our tangent is of the form of x equal to h or x equal to k. So therefore, I can just do my conclusion. The required tangents parallel to the y-axis are x equal to 0, x equal to minus 0.0385, and finally x equal to minus 4.88. Alright, now let's continue to take a look at part B of this question. We are given that now the tangents found in part A, the 3 tangents that we have found, make an acute angle of pi over 6 radians with the line y equal to mx plus c. Again, for this type of question, I will suggest to draw a simple diagram for our own reference. Say this is the axis, and we can just choose any of the tangent. Maybe we can just say x equal to h, and this line y equal to mx plus 1, y equal to mx plus 1, it makes an angle of pi over 6 with any of this tangent. So from this diagram, actually, I can immediately see that the angle that the line that makes with the x-axis, right, will be given to be pi over 2 minus pi over 6, right? Because this is a right angle. And this will give me pi over 3. And we are going to make use of one of the theory that we learned in secondary school before. And when we have a line y equal to mx plus c that cuts the x-axis here, say the angle is given to be alpha, I will be able to write down the gradient of this line m is in fact equal to tangent alpha. Alright, reason is because tangent is defined to be opposite over adjacent, or the rise over run. We can just imagine that this is the rise, this is the run. And it happens that this is also opposite over adjacent. Therefore, the gradient will actually be defined to be tangent alpha, right? Because the tangent, the gradient of this line is equal to just m. Right, so from here, since we know that this angle, right, pi over 3 is the angle that the line makes with the x-axis already, we can just write down m is equal to tangent pi over 3. And it will just give me square root 3. Alright, but we shouldn't forget, actually, we are only considering one case whereby the gradient is an upward sloping. There's a possibility that the line for this one, the gradient can be downward sloping in this manner. So if it's downward sloping in this manner, basically it's just like a mirror image of this one. And since the gradient of this line is pi square root 3, the gradient of this line will just simply be minus square root 3. So therefore, the other, maybe I can just call this m1 equal to square root 3, m2 is equal to minus square root 3. So therefore, let's do our conclusion. Therefore, m should be equal to plus and minus square root 3.